All right. This week, as I said last week, is a bit tougher than last week. Last week was fairly easy with slope fields, but slope fields deal, if you ever see a problem on an AP test, the slope field problem and the separation of variables problem is usually on the same problem. Okay, so let's review a little bit about, well, here's the pace chart for this week. Now, you have to realize that there is a practice AP exam over spring break. Now, obviously, when you get done with this week's material, you can always do it anytime you want. It has 4 parts to it, just like the AP test does. 2 parts are multiple choice, or 2 parts are calculator, and 1 and 2 parts are non-calculator. So obviously, I don't know what you're using when you take the test, but well, this one is not. You can take as much time as you want on it. Obviously, the AP test is timed. All right. So last week we talked about slope fields, and this week we're going to talk about slope fields with separation of variables. Um, the slope field, we'll just review here. When they give you a slope field problem, basically all you're going to do is you're going to, all the points, you have to find a slope and then draw that slope in. So I always, oops, I want to make this a little bit smaller of a line here. Okay, so I usually just put down all the points. So in this one, I have 0, 0, oops, 0, 1, 0, 2, and let's see, I've got 2, 0, 2, 1, and 2, 2. So not a whole lot of points. Usually they make you do a whole lot more than this one. So 0, 0, if I put 0 in here, 0, it's going to end up being 0 over -1, which is just 0. 0, 1, so that's going to be -1 on the bottom and 1 on top. So -1 over, so that's -1. If I put 0, that's -1 on the bottom, that's 4 on the top, so that's -4. Then if I go to 2 here, so 2 minus 1, so that's going to be 1 on the bottom always. And then 0 on top, so that's 0. And then if I put 1 on top, so that's going to be 1. And if I put 2, there's going to be 4. So here's all my values. So at 0, it's going to be 0. At 0, 1, it's going to be -1. At 0, 2, it's going to be -4. Then at 2, 0, it's 0. At 2, 1, it's 1. And 2, 2, it's 4. So that's what my slope field would look like. Then part B on this one, and as I said, most of the times you have an A, B, and a C part. We don't know how to do the C part yet, so we'll just do the A and B. In this one, it says let f of x be a particular solution to the given differential equation with the initial condition 2, 3. So they just gave me the point. Write an equation for the line tangent to the graph of y is equal to f of x at x equals 2. So that means my point's going to be 2, 3. So what is my slope? Well, I'm given a function to find the slope. So if I put 2 in here, that's going to give me a 1 on the bottom. If I put 3 in there, it's going to be 9. So my slope is going to be 9. So I can write an equation. Y minus 3 is equal to 9, x minus 2. Now, usually we leave our answers in point slope form. Unless it tells us to write it in a different form, we usually just leave it in point slope form. Then it says use your equation to approximate 2.1. If I put 2.1 in here, 2.1 minus 2, that's 0.1. 9 times, that's 0.9. So I have y minus 3 is equal to 0.9, so y is equal to 3.9, if my math is correct. Okay, so this was an AP question in the past. And as I said, all AP questions are worth 9 points. You're trying to score 5 on each one. If you can score 5 out of the 9 points, you would get a 5 on the AP test. That's just the way it works out every year. So let's take a look at the answer key here. Here's the answer key for the slope field, and it looks like you'd end up with 2 points for the slope field. So that's pretty good. So end up with 2 points here. All right. And then 2 points in order to write the equation of the tangent line. So y equals 9 minus 2 plus 3. So we ended up with, and the approximation. So we ended up with 2 more points. So we already have 4 points without having to do the hard problem. And this is a hard problem. I mean, there's 5 points total in this problem. And you get 1 point for just separating the variables, 1 point for taking the or 2 points for taking the antiderivatives. So you should get 3 points here. And I'll show you how to do that in just a bit. But you'll see that all free response questions, they start off easy, and then they get harder and harder as you go down. But usually the first couple problems, you should be able to get 4 or 5 points off of that. And then there might be parts of the problem that you won't be able to get. That's just the way it goes. But, this was I'm not even sure what year this was, but it's a good problem. So this week we're going to work on what is called separation of separable differentiable equations. Is it hard? Yeah, it is. I mean, there's some tough problems out here. Here are the steps, okay? Separation of variables is a special method to solve some differentiable equations. If I gave you 5xy and I asked you to find the derivative of this thing, or the antiderivative, if this is the derivative and I want you to go backwards, there's no way you can do it. I mean, using what we know, there's no way of doing this. Even if we use substitution, still would not work. So we have to find a different way of doing it. So this is the method. When can we use it? Separation of variables can be used when all the y terms, including the dy, can be moved to one side of the equation, and all the x terms, including the dx, can be moved to the other side. And that's why it's called separation of variables. We're putting the y's on one side, we're putting the x's on the other side. That's why it's called separation of variables. So what are the steps? Step number 1, move all the y terms, including the dy, to one side of the equation, and all the x terms, including the dx, on the other side. Okay, so you just move them. Just move the x's on one side, you move the y's on one side. Step 2, integrate one side with respect to y and the other side with respect to x. Don't forget to add c, the constant of integration. And then step 3, simplify. Okay, sounds easy enough. I mean, only 3 steps. How hard could it be? Yeah. All right, so let's take it. And here's how they show it in our textbook. I think the other notes are a little bit easier to follow. So in this problem right here, and usually separation of variables, they give you a point that you have to plug in so you can find the c value. Okay, so in this problem right here, it says solve for y. So at the very end, we want our answer to be y is equal to some function. Okay. Step 1, separate the y's and the x's. So I have dy over y squared is equal to x squared dx. Okay. Any questions on that? All I did was I divided both sides by y squared to get the y squared on this side. I multiplied by dx to get the dx on this side. Okay. So now I have my equation. Now I might rewrite this as dy, I might put this up here, y to the negative second dy is equal to x squared dx. Okay. Now I'm going to take the integral of both sides. Integral here, integral here. Well, here, remember, we're just adding 1. So this is going to be y to the negative 1 over negative 1 is equal to x to the third over 3 plus c. Okay, now you have to add the c, and you only add it to the right-hand side. Now, a lot of students, this is where they really blow my mind here. Since I have a negative exponent, I'm just going to put that on the bottom. Okay, so that becomes this, right? So the negative 1 I can put on top is equal to x to the third over 3 plus c. Now, a lot of students, they want to solve for y is equal to first. You do not want to do that. you want to plug the values in to come up with your C value right now. Okay, we want to find C. So that's a fairly easy step. This was the hard. Well, I shouldn't say this is the hard step. This is not too bad. This is not too bad, plugging the x and the y in. So my y value is 3, so that's going to be negative 1 over 3 is equal to, and my x value is 0, so 0, that's 0 plus c. So my c value is negative 1/3. So my equation now is negative 1 over y is equal to x to the third over 3 minus 1/3. Okay. Take a look at it. See if you disagree with anything or if you have a question about anything. Okay. Now, to get rid of that negative 1, I could just multiply both sides by negative 1, right? I want to get this to be positive. So I'm going to multiply everything by negative 1. So that's going to make that a positive here. So far, so good? I just multiplied everything by negative 1. Okay. How do I get my equation to be y is equal to? Because right now, it's 1 over y is equal to negative x to the third over 3 plus 1 over 3. My answer has to be y is equal to. This is not y is equal to. This is 1 over y is equal to. How do I get it to be y is equal to? How can I solve that? And that is probably the hardest part of these types of questions. Times it by its reciprocal. So what are you saying? Just flip everything over? So y is equal to 3 over negative x to the third plus 1? And that is absolutely correct. You can do that. If you had a problem like 1 over y is equal to 3/2, you could rewrite that and say y is equal to 2/3. You can just flip both sides. Not many people know that. So here's my answer. This is it. Y is equal to 3 over negative x plus 1. That is it. It's kind of a, and I mean, there's quite a bit of work to do to get to that point. And the last step usually is that one that really messes kids up. So far, so good? All right, let's try another one. Now this one is a obviously an AP question, and this is something that you might see on your homework tonight. So the first part, you do the slope field. I don't want to do the slope field. Okay, that's just a kind of a waste of time. I think this slope fields are so easy to do. It just takes time. So we don't want to do that. I mean, but we could. I mean, we could definitely do that. So we're going to cross out A. Then it says write an equation of a line tangent at x equals -1. Okay, so we'll just say we did this because do I have the answer key at the end? Okay, so we do have the answer key. So so let's just say that we know how to do this first part. We don't want to spend our time on that, but we're going to say we're going to get all the points for it, right? Because we know how to do it. I saw your homework last week. You know how to do slope fields. So we're going to say we're going to get all the points for part A. Okay, boom, we got them. Part B, it says write an equation for the tangent line of the graph. Okay, so this is part B, and usually it's something like this for part B. So how do I write an equation of a tangent line? I need point and slope. Well, guess what? They gave me the point, -1, 2. And the slope, well, I'd plug it in here. I've got -1, so if I put it in here, -1, that's +1. If I put 2 in here, that gives me 4. So 1 times that's 4 over 2. So my slope is 2. Write an equation of tangent line, not a problem. Y minus 2 is equal to 2x plus 1. Okay, so far so good. Are you okay with that? So that would be the second part of that AP test question. Wouldn't it be -2? So negative is a positive. 2 squared is 4. I'm going to say it's +2 for this. Are you saying the slope should be -2? But it has a negative in front of here. So it really be negative. So it's really -1 times x times y squared over 2. Well, my x value is -1. So if I put -1 in here, I get -1 times -1, which is +1 times y squared, which is going to be 4 over 2. So I think I'm going to stick with +2. Okay. All right. So here's my second. So this is part B. Okay. So you're probably going to get a point here. You're probably going to get 2 points here. You know, sometimes you'll get 2 points for the slope field, not often. So I'm thinking we're probably around 3 points right now. Okay. Where's the rest of the points? Well, the rest of the points are right here. It says find the solution y is equal to f of x to the given differential equation with the initial condition f of -1 equals 2. So basically what they're saying is we want to write an equation y is equal to. They want the original equation. So we have to use differentiable equations. So in this problem, so we have dy, and I'm going to try to write small because this is going to take up a lot of room, is equal to negative x y squared over 2. So I might bring the 2 over here and the y squared. So I might rewrite this as 2 dy y squared is equal to -1 x dx. Okay, is that okay? All I did is I separated the variables. Usually you get a point. You usually get 1 point just to separate them because they give you a point for everything you do on the AP test. So I'm thinking I've got a point already. Now I'm going to bring that y squared to the top. So I really have 2y to -2 dy is equal to -1x dx. Okay, stop me if there's something that you don't understand. Okay, so far so good? Okay, now it's time to take the integral. So I'm going to take the integral of both sides. So the integral of this one, so if I add 1 here and put it over, so this is going to be 2y to -1 over -1, but I'm just going to put that negative in front of the 2 here. So it's really going to be -2 over y is equal to, well, if I take the integral of this one, I end up with -1x squared over 2 plus c. All right, so I've gotten to the point where I've taken the integral of both sides. Now I have to find the c value. How do I find the c value? Well, they gave me a point. They told me that when x equals -1, y is equal to 2. So I'm going to plug that in there. So I'm going to put 2 in here. So that gives me -2 over 2 is equal to -1 and then -1 squared. Well, -1 squared is 1, so I still have -1/2 here plus c. I'm going to add 1/2 to this side. So this is really -1, isn't it? And I'm going to add 1/2. So isn't my c value -1/2? For my c value? I think that's my c value. And usually you'll get a couple points to get to this point. Well, usually you'll get 2 points to do this. You usually get a point to find the c value. So now what do I have? I have -2 over y is equal to, what do I have here? -1 x squared over 2 minus 1/2. I'm going to multiply through by -2 now. And the reason I'm doing that is because that'll give me 1. I'm going to write it over here. 1 over y is equal to, multiplied by -2, that gives me 2x squared over 2 minus, it's going to be a positive because it's a -2 there, 2 over 2. So 1 over y is equal to x squared plus 2. I'm going to put that over 1. Now flip it. Y is equal to 1 over x squared plus 2. Whew. All right. Let's take a look at the answer key. So here's the answer key for this AP question. Problem number 1, we said we're not going to do the slope field. Oh, look at that. You got 2 points for doing the slope field. So we're going to assume that we got those points. Okay, so that's 2 points our side. Part B, we only got 1 point to do the equation. All right, so we got that right. So we have 3 points ready. We're only looking for 2 more points, okay? Now, if we can get all 6 of the points, that would be sweet, but sometimes you don't get them all right? So in this problem, I'm looking at this, separate the variables. Okay, so here's the variables. They left the 2 on this side. Okay, they didn't bring the 2 over to the other side. Makes no difference. It does not matter at all. The only difference you're going to see is you're going to end up with a slightly different C value, but it's not that big of a deal. Our answer is exactly the same thing. If you go back, okay, so if you're going to put a 4 under there or over there, you can do that and you're going to get the same thing. And this is where it gets a little bit tricky when you're doing this, the separation of variables. I brought the 2 over here because I thought it would be easier to get rid of that. You can leave the 2 here. It makes no difference. You're just going to end up with x squared over 4, but it doesn't make a difference. Okay? It makes no difference what side you leave it on. Okay? Because our answer is exactly the same. If you put a 4 on the top of ours, you're going to get the same thing. So a lot of times when you're doing the separation of variables, when you get to this point, and that's why I always tell students, plug the value in as soon as you get as soon as you take the integral, you want to plug the C value in. Because I've had kids where they've multiplied through and then their C value doesn't even come close to what it's supposed to be. And that, so my suggestion is as soon as you take the integral and you get the y is equal to, plug that back in to get your value. It's gonna help you out immensely. All right, so it's probably one of the easier types of problems to get full credit for. All right, this one. This one I am going to let you work on, okay? It's probably, it's a tough problem. There's no question about it, okay? But I want you to try it and see how far you get on the problem. And then we will go through it step by step. And as you're working on it, I'm going to go and open up your assessments for this week so you don't have to worry about that. So what I want you to do is just work on it, see how far you can get on this problem, okay? And I will be back in a bit. Nope, you will never, I shouldn't say never, but you really shouldn't have to do well, okay, all right. You mean when you're taking the integral of u or e to the 2y? Well, usually, okay, so let's say we do e to the 2y. So I would let u equal 2y, then du or dy du is equal to 2. So then if I plug this in here, then I got dy over du or over 2 is equal to dy. So I could end up with e u times, and then we'd have 1 over 2, right? Or that would be dy over 2. Take the integral of e to the u. E to the u is just e to the u over 2, and then plug it back in. Now, you'll learn after doing this many, many times, and that's why I said you really don't have to do it. If you had e to the 3y, it would be e to the 3y over 3. If you had e to the 4y, it would be e to the 4y over 4, so forth and so on. And so it's just going to be the derivative on the bottom. So that's why, when I thought about it, it's like, you don't have to, but you could. I mean, you actually could. You could just set it up and use substitution. But once you do it enough, you'll see that you don't need to. Okay, so let's work through this problem. First step, I'm going to separate. So I've got e to the 2y dy is equal to 3x squared dx. I'm assuming you got that far. And then I'm going to take the integral here. So that's just going to be e to the 2y over 2 is equal to 3x squared or 3x squared, which would be to 3 here over 3. So that would just be x to the third plus c. Okay, so far so good. Now I would plug my value in. Okay, so it's 0, 1/2. So I'm going to put 0 in for x. I'm going to put 1/2 in for y. So that's going to give me e. Well, 2 times 1/2 is just 1 over 2 is equal to, and that's going to be 0 plus c. So my c value is going to be e over 2, which is a kind of a crazy looking c value, but it's okay. So now I have e to the 2y over 2 is equal to x to the third plus e over 2. All right. So far, so good? I'm going to multiply both sides by 2. Gives me e to the 2y equals 2x to the third plus e. Okay. So far, so good? And I'm going to stop here. I want you to rewrite this as y is equal to. And as I said, a lot of times, separating the variables, that's not too bad. Taking an integral, sometimes it's hard. Then you have to find the c value, okay? But sometimes rewriting this to be, oh, look at that. All right, so natural log of 2x to the third plus 1. Okay, so I'm gonna do this. I'm going to talk about this so kids that are watching this video will know what we're doing here. If you had something like 2 to the third power is equal to 8, we can write this as a logarithm. So that would be log base 2 of 8 is equal to 3. Now, if you had e to the 3 is equal to, I don't know what that is, let's just say x, I could rewrite this as log base e of x equals 3. Well, log base e is natural log. Well, that's what I did here. I rewrote this as a logarithm. So I rewrote this as log base e of 2x to the third plus e is equal to, what was that, 2y? Well, log base e is natural log. So that's natural log of 2x to the third plus e is equal to 2y. Well, remember, we want to get y equals. So I'm just going to divide through by 2 or multiply by 1/2. So y is equal to 1/2 natural log 2x to the third plus e. Pretty awesome. Now, I don't know where your 2 ended up because you didn't have a 1/2 in there, but you did. Oh, and where did you get that plus 1 from? Because remember, our c value was e, right? So you're on the right track. All right, so here is the work for that problem. And, you know, you get 1 point for separating the variables, 1 point for taking the antiderivative in terms of y, 1 point for taking the derivative or the antiderivative in terms of dx. So those are all easy points to get. 1 point for coming up with c to be e, and then another 2 points for coming up solving for y. Y is equal to 1/2 natural log of 2x to the third plus e. So that is a 6-point problem on an AP test. I mean, they are, you know, they're not the easiest problems in the world. But, you know, if you take them step by step, separate the variables, take the integrals of both sides, find your c value, and then use some math. Because, I mean, really, all of the work that we did was fairly easy until we got to this point, right? And this point, you have to rewrite. Oh, I suppose we got the c. But trying to get this bad boy into y is equal to, a lot of kids wouldn't know how to do that. All right. I think we have one more problem today. Oh, I think we have a couple problems because they're just multiple choice ones. Oh, no, that's not a multiple choice problem. All right. So we'll go back. So this is a multiple choice question using finding the general solution here. Now, this time we don't have to find c. They didn't give us a value. So step 1, rewrite it as dy. So I'm going to go 8y squared dy is equal to 5x squared dx. We take the integral of both sides. So this is going to be 8y to the third over 3 is equal to 5x to the third over 3 plus c. All right, now I'm trying to get y is equal to, so I probably would multiply both sides by 3. Now, this is where kids really struggle. Okay, so I'm multiplying both sides by 3, so that crosses out. So I'm left with 8y to the third is equal to 5x to the third plus 3 times c. Now, if c is a constant, okay, any constant, doesn't matter what the constant is, does multiplying by 3 change it? Is it a different constant? No, a constant is a constant. Regardless if you divide by 3, multiply by 8, that c does not change. It's still a constant. It's a constant. So it doesn't matter if I multiplied, it's still a constant. I mean, it's, you know, we don't know what it is until they give us a value to find that c. It doesn't matter what you do to c. You could multiply it, you could add numbers to it, you could do anything. Still c, it's still a constant. So my last step here, well, I guess it's not my last step. I'm going to divide through by 8. But dividing c by 8 doesn't change c. It's still a constant. So this is going to be y to the third is equal to 5x to the third over 8 plus c. And that c is still a constant. And then my last step, I'm going to take the third root of both sides. So y is equal to the third root of 5x to the third over 8 plus c. That c only changes if we give it a value. If we start off and say, okay, you know, our initial value is, you know, f of 1 equals 4 or something like that. Then we can find what c is, and then c does keep changing every time we do something. But if you just have a c, just a normal c, and you don't figure out what it is, it doesn't matter what you do to it. You can multiply it, you can divide it, you can do anything, still c. doesn't change, which is kind of a weird concept, but it is what it is. All right. Here it says, for each problem, find the particular solution of the differentiable equation that satisfies the initial condition. Okay, so we have two problems here. For, oh my goodness, that is a terrible value. We're not going to do that one. Yikes. All right, we're going to cross that one out. So we're going to do this problem. I'm going to let you take some time. I'm going to let you find the C value and all that. See what you get there. Okay, so work on that problem. And that will be our last problem for today. All right. Now I haven't done the problem yet, so I don't know what the answer is. 0.46 seems a little weird, but it obviously could be. All right. First step, I'm going to separate the variables. So I end up with dy over y squared is equal to 2x dx. I'm going to rewrite this as y to the negative second dy is equal to 2x dx. So separated the variables. Next step, I'm going to take the integral of both sides. Well, the integral of y to the negative second is going to be y to the negative 1 over negative 1 is equal to the integral of 2x is going to be 2x squared over 2 plus c. I'm going to cross that out. I'm going to rewrite this as negative 1 over y is equal to x squared plus c. I just kind of rewrote it. My values, so I've got negative 2. So if I put negative 2 in here, negative 2 squared is 4 plus c. And then I have negative 1/5. So that's going to be negative 1 over negative 1/5, which turns out to be positive 5, if I'm not mistaken. So I end up with 5 is equal to 4 plus c. So c is equal to 1. All right. Did you get c equal to 1? Ah, that'll make a huge difference in your answer. That's where you came up with that 0.46. Kind of looked a little weird, but that's all right. So then now I'm going to put the 1 back in for c. So I have negative 1 over y is equal to x squared plus 1. I'm going to multiply through by -1, so I end up with 1y is equal to -x squared minus 1. And then I can put this over 1, and then I'm going to flip it. So y is equal to 1 over -x squared minus 1. That would be my separation of variables. Okay, so everything else was okay except plugging in the point in the wrong spot. Awesome. Any questions on this stuff? Because that is basically what we're doing this week, separation of variables. All right, so the last slide for today. Have an awesome spring break. You should be all set to go on your assessments. I did open them up, so you should be ready to go. Have a great spring break. Bye.